My name is Andriy Syrotyuk. I represent the Karpenko Physico-Mechanical Institute of the National Academy of Science of Ukraine. I would like to present a report entitled Fracture Behavior of Pipeline Steel Depending of Hydrogen Content in the Material. Is plan my presentation. The main and secondary pipeline network is the critical components of many countries' industrial and transport infrastructure. The problem of ensuring their reliable and accident-free operation is always of agenda or in engineering practice. The importance in the problem is the increase with the large-scale use of hydrogen as energy source and creation so-called hydrogen energy infrastructure. Today, hydrogen is mainly transported the gaseous state by pipeline system, which prefer other methods. As the two variants of hydrogen transportation are used, and by existing natural gas transportation system with additional 10–20% hydrogen gas. It's the difference investigation other in the another investigation made this our main investigation is this field have substantial disadvantage. The true level of the hydrogen content is metal was unknown. In this value was taken in account indirectly. Our presentation removes this problem, and our stage work we know hydrogen content in material. We used the parameter WF, which is the energy spent in specimen fracture of given content hydrogen in the metal. This parameter characterizes the hydrogen content in the bulk in the hydrogen bank content. We studied typical carbon pipeline steel, and we produce two type specimen, beam specimen with notch, as the maybe some types the corrosion defect, and next case the beam specimen with crack. In the experimental, we use the special chamber for gaseous hydrogen charging, and for examinate hydrogen content, we use the analyzer LECO, which know hydrogen content in the material. For the we determine the total hydrogen content is the diffusible hydrogen content and residual hydrogen content. For this procedure was applied with basis of next following suggestion. We consider the diffusible hydrogen as the hydrogen which is present in the lattice and the weak traps. The radial hydrogen is the hydrogen which remain in the deep traps. And we have assumed the total hydrogen content in the specimen after the hydrogen charge is assumed the diffusible hydrogen content and the content of the residual hydrogen content. After we tested material in the air and pre-charging specimen, and we have, as a result, we have the some groups dependence. For next step, the analysis. After testing, we use the scanning electronic microscope for the analyzing surface fractured surface. And after test, we build diagrams, parameter VF, CH. This case for the fracture resistance of notched specimen. In this diagram, we see three zones. The first zone in the energy spent, practically no change. The next zone, the parameter VF decrease, and next slowly increase. But we most correctly say not zone are the range of hydrogen contents, CH. This range, and this range. And for our zone, we characterize fracture after fracture analysis, and you see the first zone, the typically damages after ductile fracture, the voids and some dimples. The second zone is maybe say the transition zone, because see the some defect typically for the dimple fracture and brittle fracture. This some transition zone from the dimple to the brittle fracture. And second zone, you see the typically defect for the brittle fracture. You see the micro cracks and quasi-qualish defects. The similar investigation procedure used for the next case specimen with crack-like defects. The similarly affect the change the parameter VF and next zone. And yes, similarly analyze from the scanning electronic microscope. And you see now the first zone characterizing the typically defect from the dimple fracture, the transition zone, and zone characterizing the brittle fracture. And next step, our investigation, the construct diagram on the influence on the hydrogen content of fracture behavior of low alloy pipeline steel. we propose a parameter, the showing laws of steel fracture resistance depending of hydrogen content in the metal. This parameter dependence in the fracture spent for the specimen without hydrogen charging and energy spent from the after charging. And we construct this diagram, and we show the three zones. The first zone, the zone is the safety exploited pipeline, and maybe the must see the hydrogen content in the material. It's this second zone in the transition zone, and the third zone at the zone and critical concentration, and this zone in the zone hydrogen embrittlement. And short conclusion. Okay, thank you very much.